Good evening, team. Welcome back. I'm Corey, and we're hopefully about to finish up day 12 of Advent of Code in Rust. In case you missed the first part of my day 12, check out the previous video up top. If you missed any of my previous solutions, check out my full Advent of Code playlist, and don't forget to like and subscribe for more videos. Let's jump right back into day 12. Thanks, Bobby, for the encouragement. Okay, let's jump back into day 12. Okay, so to refresh our memory, this problem is about getting a maze like this, where A is a low elevation and Z is a high elevation, and you can only go up one elevation at a time, and it's about finding the way around the maze where you can get from A to Z, or from S to E, start to end. And so for this example, the shortest path is 31 steps. And our solution, doing an A prime, does get 31 here. But if we do it for the my input, we get, at the moment, we're getting 441, which when we plug that in here, it says our answer is too high. So we're going to need to work through and figure out what's going on. And we've done that a little bit already, and we had a few examples here where, like, the target position and starting position are parsed correctly. This wasn't working exactly right at first. And then over here, the neighbors of the starting position weren't giving the right things at first, so we were testing that. And we're probably going to continue with these kind of tests here. Okay, so let's see. So the starting positions from, and I guess maybe one of the things we should do is we could start moving to the my input for some of these tests and make sure that, like, we'll test some of the basic stuff for the my input maybe. So for the my input, let's test the target and starting position. And so let's see if we can just visually find the capital S. Nope, but the computer can do it for me, I think. There it is. Okay. So it's in line 21, column 1, so 20, 0, 20, 0, 20, I think. So starting is 0, 20. Oh, whoa. Is that parsed correctly? Yep. Okay, awesome. And then ending at 92, so 91, 20. Over 91, 20. Awesome. Okay, so how many neighbors does the my input have? These are probably not the bugs because it wouldn't really make sense. My starting, okay, so from the my input, we're starting here. You can go in two directions, up and down. Ooh. There we go. That's interesting. Ooh, it says 3. Okay. Yeah, ooh, we have Copilot still on. We're gonna turn that off, but Copilot did get that right here. Just for the video, I feel like we're gonna leave Copilot off for no good reason. Thought, is it just length on a vector? Yeah, that makes sense. Let's debug out RN here. Reference here. There was something I didn't like up here, wasn't it? Oh, was it just that N was unused? Maybe. Okay. Delete, 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 delete. So it thinks that there's 3 neighbors. But if we look at my input, oh no, there are 3 because this one's a valid because you can go up to B. Wait. Yeah, you can go up to B because this is the same height as an A. Okay, yep. Okay, so this is actually correct at 3. That's just unfortunate. It's fine, but unfortunate. What don't you like? Oh yeah, it's just saying you don't have to. That's actually a pretty nice clip. He's telling us that if we made it a vec just to count the length, we don't need to do that. Okay, so all we did though is prove that their other 2 fixes don't also apply. So what do I want to do next? Can I print out the path in a better way? Can I print out the path like they're printing out the path? Just because I guess I don't have a better idea of how to print out the path than this. But we can probably print out the path like this. It's not gonna be trivial, but we can definitely do it. We're just gonna have to do an invert, like get the move from a thing and put that character here. Okay, like, is that the best thing to do though? Okay, and we get 441. Oh man, I don't think I can solve this at all easily. But it does the lettering, the fact that they're letters is interesting. It means like you can like flood fill, like you can fill all the C's. All the C's are like basically the same thing. So like to get to the Z's, maybe X, Y, and then X, T, U, V, X, yeah. Okay, yeah, I can't just trace it backwards super easily. Um, and I don't have a thing to compare it to in the example now. Because I think like I've already, well, this one where part 1 just does count steps and count steps. Oh, it does debug out the actual path. Awesome. Um, no, I don't want to actually debug it. That's fair. I do want to see the debug output though. So the path we go from 0, 0 to 0, 1, but that's again this one. 0, 0 to 0, 1 to 1, 1 to 2, 1. Yeah, this one definitely does it right. I guess I should, well, my path is just too long. So if my path's too long, that means, like, is there a neighbor that I'm disallowing that I should allow? It kind of seems like it. So let's go up to my neighbors. So all directions into iter map the original dot indirection. Filter the ones that are inbound. The C is greater than 0 and C is less than width, and C dot 1 is greater than 0 and C dot 1 is less than height. Yep. And the height is the first length, width is the second length. Yep, that's also right. Filter height plus 1 is greater than or equal to the height of the new one. That looks right. The neighbors of this coordinate and the ones you can get to, like the actual like neighbors are where the height, this plus 1, like this, yeah. Climbable height is this plus 1, and then this is just climbable height. This doesn't change the code at all, but maybe it makes it more clear for me. But like that's correct. I don't know what I'm moving into this, but it's fine. Um, yeah, and that does do an iterator. And the height thing does the starting and ending correctly. Yeah, because this is already a U8, so these just map that to that. Up, down, left, right are our directions. Okay, so let's look through, let's actually read through our A star that we've got. So we've got paths from, and so at the end of the last video, I looked at another Rust A star that I've written moderately recently, but you know, for a project recently-ish. And I had a path from that was just the paths, and I had best score from. And I don't know if that's better. I guess they were both hashed by the same thing, so I guess I like this better, the path and the distance coming together. But okay, so path from here has a coordinate path from, so this is the from coordinate and the u size. Convert to a named struct. Yeah, I'll definitely convert it to a named struct. And then this is from, and this is um like current distance or something. Current distance. Um, so much better. From is current position to 0. Yeah, this is so much better. I like that rename. Okay, and then the to search, let's do this to you as well. Let's refactor you. This is uh this is just gonna become coordinate, like to search is just C, that's fine. And this is estimated distance. When we compare the things, we start with the other one. Yeah, we do it reversed. Okay. The reason we do it reversed is because binary heap, like it says here, is it will be a max heap. I want it to be a min heap, so I reverse the ordering. So we pick the lowest distance. Okay, so we make our heap of things to search. We get our starting position. Um, What if I just, yeah, I want to change this. It's not going to be that different. But I want to do if current position dot c equals target position, then we break out. And I also want this to say while to search dot pop. Yeah. While let some while let some current position equal okay, there we go. So while we're just doing our looping a little differently, while there's things to search over, if we found it, we can break out. Else we do all of these things, and we don't need to reset current position there because that happens in our loop. So if the current position equals the target position, yeah, we're done at that point. To search dot push this one. The estimated distance there, oops, really should be 0. Oops, I'm not sure that's gonna make any difference, but okay, so now we need less mutable things too. That's nifty. Shouldn't change anything though again. This should still be 31. Yay. This should probably still be giving me the same 441. Yep, I didn't expect that to change anything. Okay, but every time we go to search something, we say if we found it, great. Um, while target position paths from, yeah, okay, we'll just blow up down there if we didn't actually find a path. Okay, so if we look through the neighbors, let existing paths as paths from the neighbor, which makes sense. Yep, because we're maybe gonna search this. This is like a potential thing to search. We say the actual cost of getting to n is the current position's estimated distance. Yep, plus 1, because that's how much it takes to get to n. Our new path is if there was an existing path and the existing path's current distance of that path was less than or equal to, no, what if I just say, oh yeah, if it's equal to, we can keep that one. Well, I could change it. Well, if this changes the answers, especially to the counts, that's bad. If it changes the answers to the paths, that's like acceptable. If it changes the answers to the counts, though, that means something is wrong. Okay, so it still passes there no matter what. But if this gives a different answer, or infinite loops. Okay, why is that infinite looping? That doesn't feel like it should infinite loop. I don't think it should do if existing path is less than. Okay, so this is just infinite looping because on the equal case where the current distance is equal to actual path, we still search it. So are we going back and forth between two? How could we be going back and forth between two though? That doesn't really make sense. So yeah, let's do it this way and add some debugs because I think equals is a better answer. I think makes more sense here, but I don't think should infinite loop like we are seeing. And this isn't like a to-do, this is like the current investigation. Just leaving this for myself in case we get lost and we forget what was going on over here. Okay, so this is infinite looping right now. Start off with just debugging the current position. I guess a reference to it since things seem like they're going to be upset. And it's only on my input. And the estimated distance is increasing, but are we going back and forth between... Oh, wait. Oh. We were just searching the same position over and over again. That's interesting. Why would we be searching the same position over and over again? If there is some... Can I do this? And actual cost is greater than... New path. If there's an existing path and our actual is less than existing path. Yeah, it doesn't. First of all, that's not gonna work anyways. But okay. Sorry, I got distracted. This is what I want to figure out. I don't think this should infinite loop if I don't make this an equal sign. Because what I'm saying, if you find an existing path and the let's just like debug out that specifically happening. Else if existing path dot current distance equals actual cost. panic, but like, what do I want to panic with? Um, First of all, let's just debug out some stuff. Maybe I don't want to panic. I don't know. Existing path doc, or how about just existing path and actual cost? Um, and then let's just to do. Let's panic. Yeah, panic with an easy to do. If chain. Yeah, I don't want to rewrite it because I'm just gonna delete that soon. This one. Okay. Um, panicked on not yet implemented because the existing path get there and okay, but that one actually wasn't that exciting. Okay. If I do continue here, then this doesn't actually need to be in the loop. This can just be there. Okay. Because now, is this still? Oops, because I still have the to do in there. That's funny. Now we'll just debug it out. Okay, so now we're looping on the same thing. Actual cost, current distance, actual cost. Like, okay, I need to find the neighbors of this coordinate. Okay, so let's go and write a test for that. I think it's 3519. Coordinate of 3519. I think that's right. 3519. Oops. Moves equal this. Our neighbors, I guess, would have been a better definition or thing for it. Neighbors, which is a vec, something. Dot collect. Assert neighbors dot count. Okay, so from 3519, 35, 36, 20. This one, oh, has 4. You can go in any direction from here. My 3519. Yeah, wait, so if that's passing, then why are we looping here on the same number? Because this is the very first thing we do. So to search dot pop. Oh yeah, can I just do to search dot like count? Length will work for me. Oh, why can't I? There we go. Took me a few tries to cancel it there. To search length. Wow, that's just the length's just huge. Is it actually gonna go down? Is it just that I made it that inefficient, but this is actually going to give me an answer? I guess the best way to test that theory real quick is to go to a terminal and just do cargo, CD to 12, because I don't want to do everything like this. And then the string here that I can look for is this. Ah! Oh, Wait, but don't I still have some debugs in here? Because if I have debugs in here, we can't trust the speed of this answer. Well, that one's fine. There's only one of those. I'm not sure this is actually gonna be any different, but I can't tell if we're infinitely looping or just really slow. And I would like to find that out because that feels important to know. I want to see if we ever get close to running out. Hmm. Oh, that's a lot more than I thought I was doing. Ah, I didn't remember that one there. Okay, there we go. Oh yeah, it's just a massive search space, but like, is it just continuing to add? Just because there's absolutely no way that's deduped, like at all. Okay, but that's interesting. But I guess that's just because like we always do the neighbors. We'll like go back and forth between two positions basically infinitely if we let it be not equal, but as soon as we make it equal, it converges to an answer really, really quickly. Like that does make sense. Well, except this one didn't. Oh, okay, that was that one. I thought I ran the one that was supposed to pass. Um, there we go. Okay, so that like kind of makes sense. I can buy that. But I just don't know why this doesn't. Okay, let's get the puzzle input again. I don't know. Yeah, that didn't change. Um, my path through these is just not as efficient as it could be. But my algorithm seems so right. The things I've tried haven't gotten me anywhere. I do think that making this was wrong investigation. Let's get rid of that there. Um, let expressions in this position are unstable. Yeah, okay. I like being able to do that. Then I could like use existing path in an and here. It's really nifty. But we can't use it right now, so that's okay. If the existing paths are current distance, existing path is paths from this thing to wherever this one goes. So yeah, we do want the actual cost of getting there. Yep, so that's the right thing. Yeah. These two, I don't like that these two. Oh, again, I can do the same thing. Oh, well, no, because I'm saving these to a variable. Oh, I don't need this. Oh no, if it does continue. Yeah. Yeah. Mm-hmm. Mm-hmm. Yep. Okay, I do need both of those. That's fine. Paths from, insert our neighbor and new path. And then our distance estimation is new path dot current distance plus the Manhattan distance of n. Yep, or new path dot c. And then I thought I had c. No field. Oh, from. Oh no, that's actually not right. Right? Because paths from, how do we add to paths from? Paths from, wait, this isn't n. Oh, from current position. Yeah, no, no, from the current position. Okay. Yep. Um, New path to current distance is no, this, so this isn't this. This is n. This is n. Okay, yep, that makes sense. This one is still gonna pass. Yep. This one will still fail. It's gonna do 441, but that's not the right answer. Assert not equal 441. That's really all I know right now. So now it's gonna fail because it's gonna give me 441. Yep. Okay, yeah, I do think I need to see where this is breaking, so I need to try to print out. I think we're gonna try to print out the thing they have in the example. So on forest, mountainside, that's what this one's called. Well, I guess we actually don't need to write it on here. We just have a path down here. No, let's implement it on mountainside. We really don't need it to be there, but I think it'll be easier. Function print path. Path is a vec of coordinates. Goes to, nope, it just prints. Okay, so the thing I want to do is path dot. I think there's a, I know this from one of the other ones. Is it dot windows? I think. Because there was the things on iterator. Path.iter.win. Oh no, it's actually might be on this. Oh, but I can do windows, and I think over continuous regions of length they overlap. Yeah, so this is what I want. So I want windows of 2. So now I'm gonna go from. So I have coordinate to coordinate, and then from this we can map, because this is a from and a to, and we can do move. Did I do direction? Direction dot from move of, and then from to. Dot collect to let moves equal a vec of directions. Map. Well, this just doesn't exist, so let's generate this. From move, coordinate to coordinate. Let x diff equals from dot 0 dot abs diff 2 dot 0 dot abs diff. I know this. Wait. From dot 2 dot 0. There's no abs diff here. Then I do let y diff equals from dot 1 dot abs diff 2 dot 1. There we go. And then we match on the x diff and the y diff. If we have a 1 in the x diff and a 0 in the y diff, that's a direction right. If we have a 0 then a 1, that's a direction up. If we have a -1 then a 0, that's a left. Direction left. Oh, why is that? U size. Oh yeah. as eye size, as eye size. Yep. Underscore goes to panic. Impossible. Okay. That finishes that. Translator. Yeah, so what is this map mad about? Takes two arguments oh, expected closure that takes one argument. Got it, got it, got it. It's that it takes one argument that just is a tuple. Oh wait, no. Window. Where this is window at 0, this is window at 1. Much better. Okay, so moves. I don't actually know if that was like really what I wanted to do though. So let's do let starting equals self dot starting position, or let's do let current mutable current equals this. Let mutable characters equals a vec of a vec of vex of vec of vex, I guess, right? Okay, so then let current and then while let some m in moves dot pop. Okay, so we have our loop. At the end we want to do current equals current dot I don't know, there's an indirection. Like I wrote a coordinate dot indirection, current dot indirection move, because that's what I called that. Does it want to reference? Of course it does. Okay. So now we can keep going while we get through current. And then I need to determine the right character. Determine correct character. So then I guess what I want to do is on my direction, let's do an impl. Let's implement a function that's called character that takes a reference to self and returns a character. We match on self. If let me just fill this out. Fill match arms. Okay, up goes to up. That goes to down. Where's the down? Cheat and do it this way. Oop. Oh, is that just a V? That's amazing. Of course it is. Okay. So now we can go direction to character. Okay, so now we have characters here. What we're gonna do is we're gonna say insert the character here is current and the value is our move dot character. We need to convert you to a character. Yep, you need to be mutable if we're actually going to do anything in here. Okay, and then after we do this, we do for 0 dot dot for y in. Don't I already have one of these for y? That. Okay. For, and then in this here, we want to do print, I'm gonna do let c equal characters dot, well, let coordinate equal coordinate at x comma y, let character equals characters dot get reference to coordinate dot unwrap or a dot. And then we print our character. Apparently we gotta do this, which is hilarious to me. That's fine. We can format string it. Okay. What don't you like about that? Consider borrowing. Okay, sure. And then here we just want to do print line. Okay, that actually should print out the path pretty well. Let's see if it works. Um, oh, I don't have a mountainside here. Got it. Forgot that I need paths, so I can only really do that right here. ms.print path. Self.print path. Actual path. Oh, and I don't actually want to pass in the whole thing here. What I actually need is just a reference to a slice of coordinates. And then now, oh, whoa. Nope, that definitely needed to be that. But then when I went to use print path in count steps, I didn't mean to do that. And then go to the actual usage, you can take a reference. Awesome. So let's, oh my gosh, okay. Get it to be the wrong answer. Okay. Well, that was easy. Well, that's just wrong. Okay, so let's go back to count steps. So actual path, when we print this out here, oh, this isn't for m in moves. That might work a little better. Nope, that's worse. Like, if anything, that's supposed to be a down, because it's what it says on my thingamabobber. Though I wonder if I did some of these backwards. I wonder if I have a bug in this. From move. Okay, so, oh, which way did I go? I went from the from to the to. Oh, I kind of wanted to do this backwards. Like, if I change this to 2, and I change this to 2, and I change this to from, and I change this to from. There we go. Oh, that path didn't change at all. Oh, because I did the. Oh my gosh, I didn't. I did diff. Okay. Okay. 2.0 minus from dot 0. The problem here is that. Oh wait, are these already eye sizes? Yeah, that's fine. There we go. Okay. I was doing it with an absolute diff. I didn't want an absolute diff there. I just wanted a standard diff. I just wanted to actually compare numbers. Okay, so now I feel like they're backwards though. Yeah, it does want to be from dot 0 minus 2 dot 0, and this wants to be from dot 1 minus 2 dot 1. Okay. My left and right backwards now too? I bet so. So if we go from this one to this one, oh yeah, right. No, right increases the x from to this one. So if the bigger's over there, oh yeah, this is gonna be negative. Mm-hmm. Mm-hmm. Yep. All of my directions are backwards. Okay. That. This actually doesn't look like this map. Aha. Okay, so this map looks different than this map. Let's look at these two maps side by side. Split to the right. I need a new thing. This one, oh wait, which one's that? That's that one. Now I need to grab this one, which we're gonna see some secret stuff I can copy paste out of this other terminal, so sometimes I do that. Oh wow, that's a fun one. Uh-oh. There we go. That's what I was looking to copy. Yeah, okay, so like this one is even wrong. It's actually wrong really quickly. Uh, um, okay, let's close kitty just so it doesn't confuse me anymore. This one, so is it a valid move? Yes, close kitty. This move where I go mine, and this one is the answer. I go on the 1, 2, 3, fourth move, right? I go right instead of down. Oh, they're both C, so they're both valid moves. Oh, that's not a meaningful difference. Oh, okay, nope, so that's just the right path. There's a difference that's not a big deal. You can to get to here from the B, you can go down right or right down. That doesn't matter. Um, okay. So I got the same path, and we did get a path for my input. Like I see one. And like it looks like it's doing the right thing. Hmm. Yeah, I'm not really sure what to do. Like that, it looks like a valid path, but the thing is saying that there's a faster path, so there's something that I'm missing. But it's so hard to know what it is. You can move exactly one square up, down, left, or right to avoid needing to get at your climbing gear. The elevation of your destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you could step to N, but not to O. That also means that the elevation of the destination square can be much lower than the elevation of your current square. Yeah, well, like I have that encoded in my answer. And the thing is that this, I guess I wanted my terminal over here, kinda. But like, get to some C's, you stay in the C's, you get down to here, you get up to here. Yeah, and then you just start going. I guess the other thing is that what if I don't want to stop? What if we don't want to stop when if we've hit the target? What if that only gets us a path, not the best path? What if you get the best path? Nope. Nope. I guess the same path. It's going to do the same thing because it's still going to find the best path, even if we have to search everything. And even searching everything, like, it's not a crazy amount of searching. Hmm. Yeah, but if I pulled off something from the tree search, it's going to be the best because of how that works. So that's an optimization that makes sense. Oh man, I am so lost as to what is going on and why I can't get my input to work right. And then 441, but it's not 441. I know it's not 441. It's the only thing I know it's not. I want to just like get some print out paths like input puzzle. Okay, the reason I did that was because I just wanted to do some silly stuff. So like uh what do I like go down, up, right, left? Um just for, for the hell of it. Same thing. The other thing that I was like moderately curious about, just because I'm curious, is I wonder if this picked the other path. I don't think so, actually. That still picked this one. It's fine. I just was curious if it would. Um, hmm. And like this looks like such a good path. Like it like looks so pathy. It gets right there to the middle where it's supposed to. What is the fewest paths required to move from your current position to the location that would get the best signal? And your current position is the starting position. That's the whole point. Yeah, your current position is the starting position, and the best signal is the ending position. What is the fewest steps required to move from your current position to the location that would get the best signal? Yeah, I don't get it. Like where, I guess like I can like it's really hard to go through and see based on this my where my thing could be better. Because like I can see the path it took, right? That output looks really nice, but I don't know where I'm gonna find something that it didn't do right. And there's not a thing. Is there anything in the list twice? Let's make sure that the lists are separate. I don't know. Count steps, actual path. Okay. Let path set equals hash set of whatever equals actual path dot iter dot collect. Assert. No, I want them to be equal. The path set dot length in the actual path dot length. Oh, we can't. If we hit the same thing twice, something very weird is happening. Yep. And then this one. Yep. We don't hit the same thing twice, but we're still getting the wrong number. I'm so close. I know I'm so close. And it's not just like an off by one. It's not just like this should be. Yeah. Make sure you're using your puzzle input. Oh wow, that's interesting. That's not the right answer. Curiously, it's the right answer for someone else. No, pretty sure this is my input. This is the same one. Yeah, these look identical. This is definitely the same one I'm using. And it's not four, it would be 441 because like I already have the -1. Like that's already corrected here. Man, this looks like it just looks like the right path. 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, yeah, like I don't know. Then we go down a few. Yeah, like this is definitely following this path. Um, hmm. Yeah, but it's going around the outside here. Okay, so I guess let's look at that here. You get to the C's and then you like go up around. You go up all the way around here down. Okay, so then you get to the D's. D, E, F, G, H, I, J, K, L, L, M, N. J J J J J J K O M N O P Q R S T. Yeah, like this is U V V W X Y Z. Wait, Z Z and Y Z over. Yeah, Y Z and then over. Y Z. X Y Z. Yeah. Yeah, like I think this is like I don't understand. I really feel like this should be the right answer. Hmm. Find a path. The path looks good. Makes sense. I don't think it's just an off by one error. The path doesn't repeat. Because you guessed incorrectly 4 times on this puzzle. Please wait 5 minutes. Oh man, okay. That's like fair, but I don't know. Okay, I might be taking a break here again, team. Thank you for coming along with me, and I hope we can get part 12 solved here real soon. Thanks. Bye.